Okay, so now maybe before moving to the most common beginner questions and some tips and tricks, I will go back to some of the questions I didn't have time to answer. Okay, so oh, there are quite a few. So the first question is, shouldn't the model be defined by the server prior to consensus? Otherwise, each client could initialize a different model. For example, if it's a neural network, each client could create a different architecture and it could not aggregate later. So this is a very valid point, because if you create some clients that use a different architecture from the server, it will actually not work. But this is not really dependent on the server initialization, because if also you have two clients that have different models, it will not work either. So I guess this, yeah, I don't know if that answers the question, but also you can definitely, I will actually go through it a bit later, but you can definitely define the model on the server side to use this as initial parameters. Does the evaluate function do local model or global model evaluation? So it's actually gonna use the global model, but with local data. So depending on what you want to call this, so each client will probably have different, will surely have different results for the evaluation, but they will all use the global model to do so. How we implement privacy preserving FL like homomorphic encryption, is any library available? So we're actually trying to develop this aspect of FL. I think we already have some differential privacy examples. And we're also currently working on sector aggregation, but for homomorphic encryption, I'm not sure. Maybe some contributors, external contributors, are working on this, but it's not currently available on Flower. This is definitely a very important topic. Is it possible for clients to share some pre-start information with the server before starting federated rounds, or vice versa? For example, if the server dedicated the number of epochs per round, dictated the number of epochs. Well, this is actually possible using the, wait, you're talking about, so for clients to share some pre-start information. So I think, wait. Because the config dict is the other way around, I guess. But you could, so for instance, that would be defining, for instance, the performance of a client and doing less rounds if a client is less performant or not. I guess that's the idea. What you could probably do in this case is that such information doesn't even need to be shared to the server, because this is just on the client side. So for instance, the client knows some information about itself. So it can use this information, for instance, in the fit function. You can just say if number of resources, just change the number of epochs. And if you want to manage this on the server side, you can indeed use the config dict and say, oh, pass some, I don't know, number of cores available, a minimum number of cores available or something. And then if this number of cores, yeah, just, there's also, I think I might actually go through it later, but we also provide for the clients a get properties function. It doesn't need to be overwritten on the NumPy client, but this is exactly what it does. But let's say so the server can query this get properties function. If it exists, then you can use this on the strategy to configure the fit round, for instance, or the evaluate round. So when you have multiple clients, is the server waiting for all clients before sending the gradient updates for all the clients? This is going to depend. Well, essentially, it will depend on the strategy you implement. But for instance, with fed average, you define a minimum number of clients that sent the fit results back, for instance. And once this is achieved, then it goes to the next round. Does Flower support vertical federated learning? So vertical federated learning is when you, instead of sharing some labels or some classes, you actually share some features between the clients. And this is not yet implemented in Flower. It's the setup is quite different. So this is one of the main reasons it's not yet implemented, but that's also a very interesting topic. Can you decouple the communications and the aggregation part of the server? Right now, the Flowers seems to serve both roles, handling communications with the client and doing the aggregation. This is actually a very interesting question, because we actually released the driver API that answers this exact question, which means that now using the driver API, you have one long-standing server that's going to be handling the communication with the clients. So the clients can deconnect, reconnect, however they want. And then we have a server that's going to just receive tasks and send them to the other server to send them to the clients. And so you can actually go check out the empty PyTorch example, which on the repo, which illustrate this. Using the initial parameters on the server strategy means just starting the FL setup with a predefined weights to all clients prior to any round. Yeah, that's exactly it. Yeah. So there's also a question about can you discuss any trade-offs between model accuracy and communication efficiency when implementing federated learning for Flower-related tasks? So I guess if I'm understanding the question correctly, one thing is that if the data distribution is quite heterogeneous, you might want to train for less epochs locally and do more communication rounds, which takes more time, so it's less efficient. And on the other side, you can train more epochs locally and less communication rounds, but that can lead to overfitting on some clients and not some, and so poor performance on some clients and so on. So not sure if that answers the questions, but yeah. There's also another question. I just noticed that you never pass data in clients methods, either fit or evaluate, and you instead rely on globals to access xtrain, xtest. Is the API accepting other args? Could we tweak, or how does the data passing should work? So this is a good question as well. This is mainly, oh, this is still running, so it's at round 3. It should be done pretty soon, I guess. Oh yeah, it's actually done. So now I can actually, with this, how can I kill this? Okay, I want to keep the server. And yeah, so here we have the losses for each round. And yeah, and we didn't actually aggregate the accuracies. This is one thing we'll see just after the questions. So for passing some parameters, you can actually here just define init function, where, for instance, you would say train set, this set, and then just define them. Oh, sorry. You can define them that way and then use self.train set and so on. So this is definitely a possibility. And then when you instantiate your client here, you can just pass the arguments this way. Is it possible to communicate with the clients before parameter initialization, for example, to collect some statistics or on the data distribution, and how? So that would be using the get properties function that I touched upon earlier. So I guess it also takes config. And then you can return, I think it's a dict of, so a string to scalars. Sorry. And so that way, yeah, this is the first step that the server is going to take. It's going to call this get properties, and then the strategy can handle the results of this accordingly. So you could definitely give the data distribution to a strategy. That's actually a very interesting approach. Okay. Can clients implement different optimizers and loss functions locally? Can all of this be initialized by the server? So locally, yes, you can here, for instance, just, I mean, this is dependent on TensorFlow here, but yeah, you can definitely change this. For how the server can change this, I guess using the config, you could here, for instance, you could have, if I write this init method here, I could hold something like this model that would be none, and then when we receive, for instance, here, if model is none, then you can just set the model using the results from the config dict that is passed from the server. And then you would say model equals, and so you could write this, for instance. I mean, you would have to redefine it because here you're just compiling on a non-object, but you get the idea. And that would be, for instance, config optimizer, let's say. Yeah. Okay, so just remove this as well. You see. Do you not think it takes longer time for training as compared to centralized ML? So this is definitely true, because if you compare the time it takes for training one epoch or something on the client compared to the time for communication, the communication part is definitely going to be the bottleneck, especially with large models. But this is sometimes it's a trade-off that you're willing to take, either for privacy reasons or because you have some data that's very heterogeneously distributed. And so using some methods in conjunction with federated learning, you can actually perform better results compared to some to individual centralized setups. Not sure if this is very clear. How can I evaluate the performance of global model for the unseen data for testing? Is there any approaches to avoid overfitting in Flower and get better performance on validation data, like domain generalization? So this is actually, I will probably take this question as a way to transition to the next topic, because I will answer this specific thing of evaluating the performance of the global model with unseen data next. So I will go back to this, switch the camera. So this part of the presentation is supposed to aggregate a few of the most common questions that we see when people start using Flower. One of the important points that I wanted to highlight was the metrics aggregation, because as we saw with the example I showed at the end of the training, we only had the loss, the aggregated loss for each round, whereas we actually computed the accuracy and returned it to the evaluate function that we can see here. We actually returned this, but we didn't see any accuracy related metrics here. So for this, what we can actually do, and this is the intended way of, this is what we intended. We wanted to make it so we could display any accuracy, any metric, not only accuracy. So what we can do is to pass a function, the evaluate metrics aggregation function, to our fed average strategy. So many of the examples I'm going to show you are basic examples, and they will mostly use the fed average strategy, which is kind of the base strategy that most other strategies build on. So they will often take the same building blocks and just change, for instance, the aggregation method, because this strategy defines other things. So here, in this case, if we focus on the function, so the on the evaluate aggregation function that we're going to use here, it will always take in the metrics argument, which is a list of tuples. The tuples are going to be, the first element of the tuple is going to be the number of examples that were used on the evaluation, and the second one is going to be what we call a metric or matrix object, which is a dictionary of strings to scalars, so any number. And this function must return a matrix, so a dictionary of strings to scalars. And so in this case, in this example, where we want to use the accuracy from the evaluate function, we will first aggregate all our accuracies. So this is by taking each, so we're going to take each accuracy from the matrix dict and multiply by the number of examples. And then in a second object, we're just going to take the number of examples, and then we're going to sum all the accuracies divided by the sum of all the examples, and we will return the accuracy. And so if we add this snippet of code to our file and then add it to the strategy, so we just directly pass the name of the function, it's not a call to the function, it's the function itself. And you can also obviously define other fed average arguments. And then once you pass the strategy to the server, it will use this aggregation function for the evaluate metrics. and should print the, in this case, the accuracy for the evaluation, and store it in the history object that's returned after the training of the server. So this is the thing we talked about before, centralized evaluation. So in this case, it's small, so I'm directly going to jump into it. What you need for centralized evaluation is to define the model on the server side and to have some data on the server side as well. So that would mean this is actually pretty similar to what we did on the example before. And we just take a subset of the data to act as our validation set. And so this is just defined before the server. And then we can define this function that we will use as a central evaluation function for our server. It takes 3 parameters: the server round, the parameters of the global server, and a config. Here we'll only use the parameters argument for the sake of simplicity, and this will return the loss and a dict from string to scalar that can be empty. And so here, this is very similar to the function we wrote in the basic example. And once we have defined this function, we can just pass it to our strategy. So here again, fed average, and this is the evaluate function argument. And then we can pass the strategy to our server, and it will, after each round, it will use this central evaluation function to see the centralized loss and centralized accuracy. So the next small tip or trick was, I think this is something that came up quite a few times with users beginning to use Flower. This is how do you use the centralized model after training? How do you use it, or how do you save it? And for this, the easiest way is to just redefine strategy. So you will just write a small subclass of, for instance, fed average, where you just call the aggregate fit method of this strategy, and then store the results in the class attribute, as we can see here, and just return the same results as the superclass method. And so now this strategy, once we instantiate it, and once we run this aggregate fit, is going to contain this aggregate weights. I don't know how to pronounce it. So then we can just instantiate the strategy and pass it to the server. And once we call start server, it will start the whole training. And at the end, we'll be able to access the aggregate weights. So then we also need to define the model. Keep in mind that we could have defined it at the beginning and initialize weight with it, use the weights that we initialized for the first step. But here we just define it at the end. At the end, it doesn't change much. And then we set the weights using the strategy weights that were saved. And at the end, we can do whatever. In this case, I chose to save the weights to any path. But you can also use the model to predict something or to test it at the end of the training. So the next little tip was using the config argument, because as we saw before, each of those methods here have this config argument. And so just wanted to give an example of how we could use this. Not sure if, I'm not sure if it's big enough, but basically the first one for the fit config, it's going to receive the server round as an argument. And in this case, we first return the batch size that's independent of the server round, and then we return a number of local epochs. That's it's 1 if the server round is below 2, or else it's 2. And so then the client will receive this config object when it's going to have to start the training, and we'll be able to use those this dict to change its training accordingly. And we can do the same with the evaluate config. In this case, we'll also use the server round to define the number of validation steps we want to run. And then we can just pass those different those 2 functions to first the unfit config function argument of the fed-average strategy, and the unevaluate config function argument of the fed-average strategy. And once the strategy is passed to the server, you will then be able to use those configs in the client side, on the client side, sorry. Okay, and the last thing I wanted to touch upon is how do you go from the server to, like, when I say server, I mean the kind of real life scenario where we have different processes for each client and server. How do you go from there to the simulation? Because I touched upon the simulation feature of Flower, but we didn't really dive into it. So I just wanted to do a quick example of this. So first, the Flower client is going to be the same. It's going to be exactly the same as before. Here you have some, here we just have some attributes, some class attributes, because we want each client to be able to hold a different version of the model, because they will all use the same, like the same file. So we need to be able to create different instances of the clients. And so once we have defined this client, we need to define a client function, which is going to be used to generate the different clients. So in this case, we first define a model for each client. Then we're going to partition the data using the ID of each client. So each client is going to have a different partition of the data. And then we can just return the Flower client that holds its own model and its own partition of the training data. And then we can just call the start simulation function, where we need to provide this client function, the number of clients we want to use. And then we can provide also some different arguments, like the resources that each client are able to use. The config object is the same, and also the strategy. And keep in mind that here, I actually also added the main available clients to the strategy, because if you run 100 clients, I think the default minimum available clients for fed-average is 2. So yeah, I need to bump that up. And yeah, one thing I also wanted to point out is that the tutorials I mentioned earlier are going to be using this simulation engine. So it can also be very good to check them out to see how it works. Okay, so I'll quickly gloss over the questions. How to pass dataset for centralized at the server end. So I guess that's referring to, oh, I need to switch. Whoops. So centralized. So in this case, the data set is actually defined as a global variable. But if you want, you can you can actually create a wrapper for this function where you provide the data set here. But essentially, yeah. I'm not sure if that answers the question. you can, yeah, right. It's like a generator for this function using different data sets, I guess. Okay, so the last thing I wanted to touch upon was the federated analytics topic and how we could use Flower, and in this case pandas, to extend the federated setting. Because what we showed before is that we can go from classic machine learning to federated learning by moving, instead of moving the data to the computation, moving the computation to the data. But the computation does not necessarily have to be a machine learning workflow. It can actually be anything we want. And for instance, analytics. So I will showcase with pandas how we can just analyze a certain statistic for a distributed data set using Flower. So I should, yeah, so that's it. Here, I'll just pretty quickly go over this. This is more of I'd say a quirk or a hacky way of doing federated learning. So here what we have on the client side, it's actually pretty basic. This is what we're going to compute. We're going to compute the histogram and return the frequencies for some specific metrics. So if I can maybe show you the data, this is what the data looks like. And we're just going to compute the histogram of this. And so on the client side, sorry, what we have is just the fit function, because it doesn't make sense to evaluate a statistic in this case. And we don't need any other functions. And so this fit function is just going to compute the histograms and return them as a list with the length of the whole data. So on the client side, it's pretty basic, but on the server side, it's a bit more involved, because we actually have to redefine strategy. So here, this is not redefining a fed average subclass. This is actually a strategy. So we need to define every class of the every abstract methods of the strategy. Most of them are actually doing nothing. Initialize parameters is none. The configure, evaluate, aggregate, evaluate do not exist, because we don't really care about evaluation. The only evaluation we're going to do is to display the aggregate histograms by putting them into a matrix dict. And for the configure fit, this is just going to be for selecting the clients and giving them the parameters. So I'm sorry, I just quickly glanced through this because it's not the most important. I guess everything happens here in the aggregate fit, where normally we get the results, we aggregate them together, and we send them back to the different clients. Here, this is a bit similar, where we're going to take the results, and here this is just the aggregation method itself, and then we just concatenate the length, because what we wanted was to have the histogram for the length of the sepals and the width of the sepals. So now we just return those two metrics, those two histograms, the length histogram and the width histogram. And this I will just run it here. I'm just going to change my environment, sorry. And so I can run, I'll also split this. Okay. So I will start a server and also need another client. Okay. I'm sorry, it's going to be small as well, but I will close the clients once they're done. There we go. Okay, and so now it's done, and we have the results. So here and here, and we can see the histogram of the length and the width here. So this was a very quick example of how we can extend on the basic building blocks of Flower, and we can do more exotic things. Obviously, this particular example is not probably not very useful, especially because both clients are going to be using the same data. But yeah, this was just, let's say, a proof of concept. And now I'm ready to take some questions, if you have any. Oh yeah, right. So the question is, when the clients send their results back to the server, could there be any benefit of sending also a subjective evaluation of this result? And so I think this could definitely be useful. I'm trying to think of names of strategies that might use this this concept, but in terms of implementation, this is definitely doable using this dict, which is, it's a bit of it's supposed to be for metrics, but you can actually use it for any purpose, and you could definitely have pass some arguments back to the server using this, and then in the strategy define, or if the I don't know what kind of metric you would use for this subjective assessment. Maybe maybe the, I don't know, the execution time, for instance, if it's longer than usual, maybe it's better to just discard those weights, or to use the results to, what to say, to weigh the results less compared to others. But yeah, it's definitely possible and could be beneficial in some cases. Oh, I see quite a few questions popping up. So, is there a way to get simple data statistics in a regular federated learning setting by just use of a simple method as data distribution? Image statistics can help debug the model. Yeah, as I mentioned earlier, here, for instance, with this example, here we do this model fit, but we could, in theory, call anything as long as we return some ND arrays. So that could be a list, for instance, for the pandas example. Or is it? Yeah, we just return this list of ND arrays. And so as long as we stick to this to these data types, it will work. And maybe also, if you want to just evaluate a statistic, sorry, after the fit, you could use the evaluate method. I don't know, but this is definitely doable. Yeah. Is there a way to stop a specific client from updating a global model if the accuracy isn't better, for example? Yeah. So I guess on the that will also be using this dict here, where we can here, for instance, we can then test it on some validation data, for instance. and return the accuracy here. And on the strategy side, we can definitely say, oh, go through all the client's results and check the metrics dict and see if this accuracy is below a certain threshold, then just don't use it for the aggregation. Can tabular data be used to train model on Android using Python? If so, can I get some source? This is definitely possible, but I don't think we have an example. We actually have an Android example, but it's I think it's using MNest. It's not using or Cypher, so it's not using tabular data. Oh yeah. Oh yeah. So the Python part would be for the server, but on the Android device, you would probably have to code it in Java or Kotlin or yeah. Sorry about that. Please, how can I set an accuracy threshold? So I guess you're talking about what I mentioned earlier here, where you return the accuracy. What I can probably do is wait. I will, because for this accuracy threshold thing, we need to define a custom strategy, which I will show you in a moment. Okay, so we'll just open the the Fed average code. I'm not sure if it's big enough. Maybe I can zoom in. Oops, that's the wrong. And I can close this, I think, yeah, here. I can actually zoom in more. Yeah, so here, so this is the Fed average strategy. And I guess the part where you said the threshold would be in the aggregate fit function. So you would just write the subclass of the Fed average class, and you could override this aggregate fit function. And here, for this, instead of using this, you would actually, oops. You would actually go in using those fit res. You would actually go to use fitres.metrics, for instance. And so fitres.metrics, and then access, in this case, the accuracy and check. So here you could say, yeah, maybe I can copy this on easier on VS Code. Okay. Sorry. So if you have this, you can here, what you could do is say, for instance, if it res that metrics accuracy is I don't know, to I don't know 0.5, for instance, and so that would act as a threshold for the results, for aggregating the results. Are the individual clients models sharing parameters with each other? Is there any communication between the clients? there's no communication between the clients, and the clients are not aware of any other clients, or they they don't know anything about. The only piece of information they have is the address of the server, and they only communicate with it. Hello, any examples that focuses on recommended systems with federated learning? I don't think we have any examples of recommended systems. I mean, I think there is quite we have quite a large community of users, so I'm sure that some users have developed examples for this. But in our examples in the repo, we try to only use basic examples with different frameworks, just to show some specific features of way of doing certain things. But we try not to dive into two specific subjects that are not really relevant to federated learning. Is the data shared between clients and server raw data, or are the parameters modified? So it depends on how you're looking at it, because the parameters themselves between the clients and what the server receives, it's going to be the same. But if you're talking about the communication channel between the two, what's actually being communicated from the client to the server, it's in bytes. It's not like it's not a Python. I mean, it's a Python object, but it's not a parameters object. So it depends on what layer you're looking at, if that answers the question. Yeah. From what I understand, at each round, new clients are created. During the training, my client modifies its data set, but I would like to reuse the obtained data set of that round. Can I save it somewhere to pass it to the next client with the same ID during the next round? More generally, is it possible to save information from one client during one round to the client with the same ID for the next round? So I guess that would be, I'm trying to understand the question, but I guess if you're talking about CIDs, that wouldn't be more about simulations in this case, because in real life, like in a real life scenario, you don't have this issue of passing the data set, but can I save it some? I think I don't see why you wouldn't be able to pass this this data set, because you can have on your Flower, so your Flower client for the simulation, you could, for instance, have a list of or a dict of CID to data set or something like this, where you would, for each CID, have this data set, and you could modify it using the CID, and then reuse it every round using the CID. There's someone who raised the hand, and then but yeah, but I'm not sure what I can do. I only have the option of chatting with the person. And I guess the sound is going to be on your laptop, right? Oh, I can put the sound on. Oh. Okay, so I think, yeah, someone raised their hand, Daniel. Not sure if you wanted to talk, or otherwise you can just use the Q&A section. But if you want to talk, you can unmute, and I should be able to hear you. Okay. Oh, someone else raised their hand.
Hello. Yeah. I was wondering, okay, so what do you think are like the main challenges, before for someone to like actually use Flower in a production setting? Like what features do you think are needed, or you could also say like they're already like implemented? Do you think it's production ready? That's my question. And whether you have any tips for production settings. Oh, thank you.
Yeah, sure. So first of all, yeah, it's we actually have some work in progress with some production systems. So it's as it is right now, it's possible. But maybe I'd say as tips, well, I'm actually doing a presentation tomorrow showcasing in 10 minutes how you can go from just a centralized setting to production federated learning setting in 10 minutes. But it's if you already have a working centralized setting, it's actually pretty easy to federate it. Then the only consideration you have, the main consideration for production system, you would have to consider the communication. If you want, for instance, to have SSL encryption, which is possible with Flower, but you just have to set it up. And maybe also you would, instead of using the start server that we mentioned here, you might want to use the start driver function for the driver API. So you can have this long-running server that's only sending tasks and receiving them. It's more geared towards production, but otherwise, if your centralized setting already works, it should be quite easy to extend it to a production system. And of course, it's always dependent on how your setup looks, if you have access to the different machines you want to work on. But yeah. Yeah, and so because today for the summit, so the summit is going to start at 1 p.m. UK. Today is research day, but if you're interested in the production, in the Flower in production, you should definitely tune in tomorrow also, because we have many professionals from the industry that have implemented Flower in production. So yeah. Um, Okay, so I guess. Oh, does Flower support only image dataset on edge devices? So no, Flower. It's actually. Yeah, this is something I'm at. I should have probably mentioned, but Flower does not depend on any framework or dataset. You can use any dataset you want with any framework, as long as you're able to put everything together. It will work without any issue. So the type of data is definitely not a problem. Yeah. So I guess we'll probably close the session in, I don't know, at 40. So if you have questions, be sure to type them in now and I'll take the time to reply. Which protocol is used for this client server architecture? So I guess you mean the communication protocol, mainly gRPC, but we also released the REST implementation of this, but I believe it's still quite experimental, but this is in some time it should be the default, might be even REST, but yeah, so gRPC or REST. Can we use several levels, I guess, of client server architecture? I'm not sure what you're referring to. Maybe do you mean that you can modify deeper levels? So modify how the communication happens? Not sure. Maybe. So I'm not sure about the levels of client architecture. Okay. For Ray, so for Ray and the Flower framework, Ray is actually used for the simulation engine. It's what allows us to simulate many clients and allocate resources to them. So, because Ray will actually create, if you, for instance, you simulate with 100 clients, it will create those clients and with those functions, but just in a virtual, in a simulated environment. Yeah. I guess that's good. Prior to 1.0, to retrieve the final model after all rounds from Flow was more a workaround. Current version as something easier. Yep. So I can maybe go back to what I showed earlier, which was oh, it's actually in the slides, I think. So that was, yeah, this example. So basically you just have to add an attribute to the strategy object that contains the aggregated weights. And then, so you just redefine, for instance, the Fed average strategy in this case. And then at the end of the training, you can just access those weights using the strategy object that you instantiated before, and then use them or save them. Yeah. And also, I'm not sure how it worked before 1.0. I'm not sure if this is the same solution or not. I cannot comment on that. Can we define our central server in a way that the clients each take turns to become the central server rather than it being static? So currently not, because so as I said earlier, only the server is aware of the clients each client is not aware of anything else, so they cannot, you would have, yeah, no, this is because, I mean, you would have to change the address every time. So this is in the current implementation. I don't think this is possible. So for when the recording will be available, I think within a week or two of the summit. Yeah, it should be available on our YouTube channel, right? What is different between the simulation and the not simulation part? Why use the simulation? So the simulation happens in one machine. So for instance, for the research setting or just trying things out, it's very useful to use the simulation. And I guess your question also relates to what I did. Well, I mean, to simulating by running different processes or simulating using the simulation engine. And one of the reasons also is the data partitioning, because if you want to do manually the data partitioning, you would have to create different clients and store the data in different places. Whereas with the simulation, it can be handled using just generating the client function. And one big part also is that Ray is gonna better use the resources compared to just running the processes concurrently. For instance, you can, if you have a limited set of resources, you can just run the clients sequentially. So this can be useful.